So yesterday we saw the graphs of basic functions. You did not have any homework for this lesson. However, you should be familiar with what the graphs of these basic functions look like. You should know that the identity function, or this linear function, looks like a diagonal line, and usually whatever x is, y is. We are going to be shifting the points from these parent functions. Then the square function, the squaring function, this is going to be a U shape. Again, if you blank out and you don't memorize what it looks like, you can always create your own table of values to get some ordered pairs. Because on the test next week, you're going to have to graph the parent and then graph the new graph after it's been shifted. And then you'd also be familiar with the cube function and the square root function. Then also you should know the cube root function, what it looks like, and the absolute value function. Know the absolute value function looks like the shape of a V. Okay, the piecewise function, this is where you're given two different expressions and you have to see which one you're going to use depending on your value of x. So notice I have x equals 4 here. So I have to look to see, does it fit here or does it fit here? Is it less than 3 or is it greater than or equal to 3? So you can see that it's going to be the bottom one. So then once I figure out which interval it's in, I take the expression 5 minus x, and that's what I'm going to use. So I take out x, put in the 4, and f of 4 equals 5 minus 4, which is 1. And then if it asks you to express it as an ordered pair, you write it as 4, 1. Because remember, what's in this parentheses is x, and then the answer you get is your y. For the f of 0, we can see here that it's less than 3, so we're going to use the x minus 2. So 0 minus 2, I get negative 2. So again, f of 0 equals negative 2, written as an ordered pair, 0, negative 2. Here's another example of a piecewise function. Again, this time we want where we got to look to see where negative 4 will fall. So we can automatically see that it's going to fall up here at the top because it's less than negative 3. So the equation or the expression I'm using is negative 2x. I'm going to replace x with negative 4. I will multiply it and get an 8. So f of negative 4 equals 8. And again, if it's asked you to write it as an ordered pair, you put what you plugged in and the answer you got. One more piecewise example. Again, this time I erased it, but they want you to find g of negative 1. So we're going to look to see which interval is it in. Notice this one is only less than negative 1, but this one is less than or equal to. So I'm going to use the top one. So I'm going to take absolute value of x minus 4, put negative 1 in there for the x, do what's in the bars, and then absolute value it. So g of negative 1 equals 5, again written as an ordered pair, negative 1, 5. Okay, so now we're going to take a look at the graphing techniques. Having memorized the basic functions of x squared, square root of x, the cube root of x, the absolute value of x, is going to help you when we shift these graphs. So, for example, on this first two, when you have something added or subtracted to your x squared, this tells you that it's a shift either up or down. So if it's a plus 1, we know we're shifting it 1 unit up. If it's a minus 1, we're going to shift all of the points from the parent 1 unit down. If it were a plus 2, we would shift them all up 2. Does that make sense? So let's go ahead and try this. So in my first example here, On the test next week, you're going to have to graph the parent. So I'm going to graph the parent in blue, and this is what was on those slides. Now let's say you blank out and you don't remember. When I teach this to my Algebra 1 and I teach them tables of values, I would tell them to do things like this and then put the y over here. So if we plug in 1, 1 squared is 1, 0, 0 squared is 0, negative 1, negative 1 squared is 1. So my table of values for the squared function are going to be 0, 0, negative 1, 1, and 1, 1. And you make your U shape. To graph the new transformed function, I'm going to take each one of those 3 points and move them up 1 time. So the 0, 0 moves up to here. The negative 1, 1 moves up to here. And then the 1, 1 up to here. So this is my shifted function, and it's been shifted 1 unit up because of the +1. So if you memorize the parent, that's all you have to do. You don't have to make a whole new table of values. So this is a shift up 1 unit. So again, this number right here tells you how many times you're going to shift each point up. If it were +5, we would have taken each one of those 3 points and moved them all up 5 spots. When it's a subtraction, yes. When it's a graph, we're going to shift it down. So I'm going to, again, graph the parent. Yes. When it has x squared minus 1, this subtracting 1 here tells me that it is a shift 1 unit down. Again, if it were a -5, 5 down. -10, 10 down. I am going to graph the parent first, so the 0, 0, the negative 1, 1, and the 1, 1. Make your U shape. And then now I'm going to take each one of those 3 points and move them each down 1 unit. And graph. Always remember though, let's say you blank out, you can always make a table of values. And you can do plug in -1, 0, and 1 into this thing. So -1 squared minus 1, and that's going to give you 1 minus 1, which is 0. Then plug in 0, 0 squared minus 1 is -1, 1 squared minus 1 again is 0. So you can always quickly make a table of values for the new function. However, remember, time is going to be of the essence. So as long as you memorize the parent, it makes it a little bit faster. Now, notice the difference here. We're adding parentheses. When a number is added or subtracted in a parentheses with the x, this is going to tell us it's going to be a shift either left or right. And when it's inside the parentheses, we have to think about it opposite. So when it's really a negative, you would think it's moving it left, but it's opposite, and this is going to be a shift right 1 unit. So when it's in the parentheses, it's opposite, and we're shifting it right 1 unit when it's negative or subtraction. If it's plus, it goes left. So for this one, again, I'm going to graph the parent. So the 0, 0, the -1, 1, the 1, 1. And now I'm going to shift all of my 3 points 1 unit to the right. So my new graph here will be this one over 1 unit to the right, 1 unit to the right, 1 unit to the right. So let me connect my U here. And then again, remember, when you have x squared, you know that when you connect the points, it should be forming the letter U. Yes. So for here, when it's in parentheses and it's a subtraction sign, this means right. When it's a plus sign, this is going to be to the left. And we're going to see that in the next example. So here, now we're adding 1 And again, we're thinking backwards when it's in the parentheses. So this is going to be a shift left 1 unit. So for here, 0, 0. For the parent, 1, 1, negative 1, positive 1. And now I take each one of those 3 points and shift it over 1 time to the left, and now connect the dots. And that would be a shift 1 unit to the left. And again, if it were a +3, we'd be moving it 3 times. Good? All right, next example. This time it's multiplying. So what this is going to show us is that my U shape is going to go up faster to get to the next point. So it's like 2 times as fast that it's going to increase up. So again, let me graph my parent, 0, 0, negative 1, 1, and 1, 1. So here it's going to go up twice as fast. So again, if you needed to see a table of values, we're going to do 2x squared. And what we're going to do is replace negative 1, 0, and 1 in it. So when I do 2 times negative 1 squared, this is going to give me 2. When I do 2 times 0 squared, it's 0. And then 2 times 1 squared again is 2. Notice the negative 1 is symmetrical. So whatever you get for negative 1, the same answer is going to be for positive 1. So again, notice it's going to go up faster. So at negative 1, it's going to be 1 up higher, and then same thing here, but it's the same 0, 0. So here's the first U, and here's the second. And it's going to go up and get skinnier and stretched out faster. Some books also describe this as a vertical stretch. So what you're doing is you're taking your arrows and you're stretching it, and it's going up faster. Yes?
Wait, so the red equation would it be the blue, or is it like the color switch, or is it?
The stretched one is the red, and then the parent is still the blue.
So the blue would be more like
Wider.
Oh, okay.
So when your number in front of x squared gets larger, your graph's going to get skinnier, because what you're doing is you're taking those arrows and you're stretching it, and it's going up really quickly, so it's going to get skinnier. If it's a fraction, it's going to get fatter. It's going to get wider. It's going to get compressed down. Okay, so here's the fraction. You're going to see that it's going to be outside of the blue lines. So here it's 1/2 x squared. So this is going to go up half as fast or slower. So like we're compressing this one. So again, 1/2 times negative 1 squared is just going to be 1/2. And then 1/2 times 0 squared is 0. 1/2 times 1 squared is still 1/2. Again, notice it's symmetrical. Those two are going to be the same. So let me graph the parent, the 0, 0, negative 1, 1, 1, 1. Make my U. Now I'll do the shifted one, or the compressed one. And notice here, when I go to negative 1, I'm going to go to the half. So it's like down here. So it's going up slower. So here, it's going to be compressed down. I know it's not really accurate, but just know that it's outside of the parent, because it's getting compressed down. Or the points are going up slower. The next one is going to be a square root. So we're going to graph the parent of the square root and then show the shift. And this one's going to be a reflection, yes. For this one, when there's a negative sign in front of it, don't think of it as making the number negative. Think of this negative sign as being a reflection. So this is actually going to be a reflection across the y-axis. And I'm going to graph it and show you. Okay, it's also going to be symmetric about the y-axis. These notes have tests for symmetry at the end. I'm not sure if I'm going to make it there today, but I will cover symmetry. This is, in addition to being a reflection, it's also symmetric about the x-axis. But let's go ahead and graph the parent. Again, if you memorize the points, it's 0, 0, 1, 1 again, and then 4, 2. Because when you square root 4, you get 2. So the graph of the parent here looks like that. Again, it's a reflection, so it's going to be negative 1, 1, and then negative 4, 2. So it's a mirrored image when it's got a negative sign in there. It's a reflection. Next one we're going to see is where it's a reflection across x. So the x-axis. When it's inside a radical or inside a parentheses, it's going to be a reflection across the y-axis. When it's outside, it's going to be a reflection across x. So for this one, notice the sign is outside. So this one's going to be a reflection across x. And you're just going to memorize these rules. So reflection across x-axis. It's also going to be symmetric about the x-axis. So for this one, I'm going to graph the parent first. So remember it was 0, 0, 1, 1, 4, 2. Then I'm going to graph the symmetric. So it's like a symmetry. So same number of spaces away from the x-axis. So 4, 2 here. Again, you can also make a table of values if that helps you. But again, the faster you can be with just shifting these things, the better. For the test for symmetry, what you're going to do to test for to see if it's going to be symmetric based on the y-axis, the x-axis, or the origin, there's rules that you have to follow. So when you're going to check for symmetry on the about the y-axis, you're going to plug in negative x. If you get the original problem, then it has y-axis symmetry. The test for x-axis symmetry, you plug in negative y. If you, again, get the original after you simplify, then it has x-axis symmetry. For the origin, when you plug in negative x and negative y, if you get the original, then it has origin symmetry. And I'll show you what this means. So I'm going to take my original function, and to test for the y-axis, remember I'm going to take out x, and I'm going to put in negative x. So y equals negative x squared. I have to simplify this. So negative x squared gives me positive x squared. So it does look like my original. So yes, this does have y-axis symmetry. Then for the x-axis test, this time I make the y negative. Everything else stays the same. And here I'm going to simplify it. I need to get y by itself. I have to solve for y. So I get y equals negative x squared minus 4. This does not look like the original, so this does not have x-axis symmetry. And for the origin test, make them both negative. Solve for y. So this becomes negative y. That'll become a positive. But then I divide everything by negative 1. And this becomes y equals negative x squared minus 4. Again, it doesn't look like the original. So for this function, the only symmetry it has is based on the y-axis. We'll try another example. So again, for the y-axis symmetry, you make x negative. So we're going to make negative x equals y squared minus 3. You can see that it does not look like the original, so this one's no. For the x-axis, we're going to make the y negative. Notice when I square it, it goes right back to my original. So yes, this one has symmetry. The origin, make them both negative. The y comes positive. It does not look like the original, even if I solve here for x. I should have done this one on this one also. -1. This becomes x equals negative y squared plus 3. Didn't look like the beginning. This one the same. It will not look like the beginning, so no. So this one has only x-axis symmetry. And then number 3, same process. We are going to make, for the y-axis test, make x negative. So negative x, square it. Once I square it, it becomes positive. It looks just like the beginning. So this one is yes. For the x-axis, we're going to make y. Notice this one is also going to be symmetric, because notice when we square it, it's going right back to positive. So this one is also yes. This is actually the equation of a circle. For the origin, make them both negative. And again, notice after I square those negatives, they go right back to what I started with. So this one also has origin symmetry. So it's yes for all 3 on that one. Testing, same process, making x negative for the y test. So I get negative 2x plus y. It does not look like the same, so no. For the x test, make y negative. And again, it doesn't look like the beginning, so no. And then here, negative 2x minus y equals 4. Again, it doesn't look like it, so this is none. None of those go back to the original. And one last example. So for here, y equals, make the x negative. Remember when you cube something, it's going to be negative, so this one's no. Here we make the y negative. Divide by -1. Y equals negative x to the 3rd. This one's also no. And then for the origin test, make them both negative. This becomes negative y equals negative x to the 3rd. Divide by -1. And yes, indeed, it finally goes back. So this one actually has origin symmetry. So you do have homework for this section. However, I'm going to change the due date to Monday. So tonight you can focus on studying for your quiz.